In this video, we will see the interior angle of a circle theorem. The interior angle of a circle is formed by two chords that are intersecting inside a circle. In the diagram, it's the angle marked in red. Opposite to the interior angle, we have two arcs that are marked in purple. These are called the intercepted arcs. It's important to note that the interior angle, although it is inside the circle, it's never in the center, because if the vertex of the interior angle is in the center, it becomes a different type of angle that's called the central angle. The interior angle is inside the circle, but not in the center. Now let's see what's the theorem. The interior angle of a circle theorem says the measure of an interior angle of a circle is the average of the measure of the intercepted arcs. If we see the diagram, the interior angle is called F, and the intercepted arcs in this example is arc AB and arc DE. If we apply the theorem to this example, we can write an equation. Let's write it down. The interior angle is angle F. That is going to be equal to the average of the measure of the intercepted arcs. We know that we calculate the average by adding and then dividing by the number of items we have. Since we only have two intercepted arcs, we are going to be dividing over 2. So we add both arcs, arc AB plus arc DE, and we divide over 2. Now let's see an example with values. Determine the measure of angle M. The theorem says that the interior angle, in this case angle M, is equal to the average of the intercepted arcs. The intercepted arcs in this example is the one that measures 32 and the one that measures 75. So in the equation we write 75 plus 32 over 2. Now we solve. Angle M equals 75 plus 32 is 107 over 2. And 107 over 2 is 53.5. And we are talking about the measure of an angle, so it's degrees. There. Let's solve a second example. If angle M equals 85 degrees and arc CD equals 68 degrees, determine the measure of arc AB. Let's write the values in the diagram. Angle M is the interior angle, and the information says that it measures 85 degrees. Now arc CD is 68. This is arc CD, and it measures 68 degrees. Determine the measure of arc AB, this arc. It's the other intercepted arc. Let's name it X to write it like that in the formula. Let's apply the theorem. The theorem says the measure of the interior angle, in this case we already know the measurement, which is 85, equals the average of the intercepted arcs. The intercepted arcs are 68 and X, so 68 plus X over 2. Now we can clear X to find the value of the missing arc. We pass it to multiplying 85 times 2 equals 68 plus X. 85 times 2 is 170. That equals 68 plus X. We can pass this 68 subtracting. 170 minus 68 equals X. And 170 minus 68 is 102. That equals X. And X is representing arc AB, so arc AB equals 102 degrees. Okay, so this is how we solve for a missing arc. Let's see a final example. If arc DE equals 40 degrees, find the measure of arc AB. Okay, so let's write the data in the diagram. Arc DE is this one, It says that it measures 40 degrees. And we are looking for the measure of arc AB. We are looking for this one. So let's name it X. Okay, we can probably think that we're missing values because the information only gives us one value, 40 degrees. But if we see the diagram, the measure of the interior angle is indicated by a square. And we know that when the arc is indicated with a square, it means that it's a right angle. That means that it measures 90 degrees. So this is 90 degrees. And with this information, now we can apply the theorem to find the missing arc. Okay, so the theorem says the interior angle, 90 degrees, equals the average of the intercepted arcs, x plus 40 over 2. We can clear for the missing value. So 90 times 2 equals x plus 40. 90 times 2 is 180. That's equal to x plus 40. We can pass the 40 subtracting. 180 minus 40 equals x. And 180 minus 40 is 140. That equals x. And x is representing arc AB. So arc AB is 140 degrees. This is how we apply the interior angle of a circle theorem. Thank you for watching this video.